Okay, if you're following the sequence of these videos, this is the first video that discusses an idea that is universal to any programming language. Okay? And that idea is functions. Functions. So in the previous videos, we looked at MATLAB syntax, and of course, that's specific to the MATLAB language. Okay. But this course isn't really about MATLAB. This course is about programming, and MATLAB is simply our vehicle to get to where we're going. Alright, so functions. You've probably heard that word before, and you know it from math class, so let's start with what you know. You probably know that you can write a function in this in these terms. Y equals f of x. And x here is the independent variable. We'll call it the input. You give me an x, you input an x, and I will do some sort of calculation, and I will return to you, or output, a number back. Okay, the number I return back to you is y. So x is the input, y is the output. This particular function has one input and one output. Now the function itself is represented by f, and this is general, but let's consider a special case. Just as a specific case here. Maybe x squared plus 1. Okay? So now you give me, let's say, 1. Okay? And I will do the calculation, maybe in my head, maybe on this little paintbrush application. But I get 2. And so you give me 1 as an input, and I give you 2 as an output. Okay? You give me, let's say, -2. Now I can do the calculation, maybe. If I'm lucky, I get 5. Y equals 5. Okay, so you give me -2 as an input, I give you 5 back. Okay, so in this sense, we can look at a function as kind of a black box. Maybe we don't care. If you're the one giving me numbers, you don't care what's happening in the black box. Okay, you give me a number, x. Here comes your number, and then I perform the calculation in this black box. It doesn't have to be x squared plus 1, it can be a different function. Okay, and then I give you a number back, y. Okay, and sometimes we don't know what's in the black box. Maybe I just give you a plot of the function. You don't know what's in the black box. So this particular function had one input and one output, but it doesn't have to be that case either. For example, you could give me 2 inputs, maybe x1 and x2, and maybe my function is to add those 2 numbers together, so I would give you 1 output. But in this case, you're giving me 2 inputs. You give me 3 inputs, 4 inputs, what have you. Maybe, the function gives you 2 outputs. Maybe you give me 2 inputs and I return to you y1, which is the sum of the 2, and maybe I return to you y2, which is the average of the 2. Okay? So function can actually have any number of inputs and any number of outputs. You can actually have 0 inputs. 0 inputs. A function that would have 0 inputs, for example, would be a function that maybe returns the number 5. So you don't have to give me any input, I'm just going to give you 5 back. Okay? Or maybe my function is to generate a random number. You don't have to give me an input, I'll just give you a random number. Okay? The function also doesn't need any outputs. Okay? Maybe my function is to make a plot instead. So you give me a bunch of numbers and I plot them. Maybe my function is to turn on an LED. Or maybe my function is to make a beep. So you send me a 1 and I beep. and then you send me a 0 and I don't beep. Maybe that's my function. Okay, that function has no outputs. So a function can have 0 inputs or more, and a function can have 0 outputs or more. Okay, so in this video, we're going to write our first MATLAB function. Excuse me. So I'm going to come over here in MATLAB, and I'm going to choose New, and I'm going to go down to Function. Now remember, in the last video we went to Script. Okay, so I'm going to go down to Function, which is different than a script. And you'll see the editor window pop up, and you'll see actually there's some text there. There's line 1, which starts with the blue function word, and then it says output args, and then it says untitled, and then input args in parentheses. And then there are some green comments. Okay, it says a summary of this function goes here, detailed explanation goes here. And then there's this keyword end. Now right off the bat, the end is unnecessary. It's telling you to end the function. It's unnecessary, it's optional. So I just delete it. And because it comes in handy later to delete it. Things get a little confusing. There are ends for for loops and there are ends for if statements and while loops. And so if we can delete an end, if it's optional, let's delete it. Just take my word for that one. So that's what I'm going to do first. Now, I'm going to write, let me delete this here. I'm going to write a function that takes a vector of length 6. Okay, as input. Okay, so I'm going to send my function a vector of length 6 as its input, and I want my function to add all of the elements. Add all of the elements in that vector. Return, or output, return that sum. Okay, that's a specific example. That's the example that I want to work through today. I'm going to send my function a length 6 vector, and I want to write a function that adds all of those elements, all of those 6 elements together, and then returns that sum back to me. Okay, so going back here to the editor, you'll see line 1. This is the most important line of any function. This is called the function header. Okay, and it's very specific, and it always has to be in this form. It starts with the blue word function. Anytime you see a blue word in MATLAB, that's a reserved word. It means something very specific to MATLAB. Okay, it's like if you tell your significant other, "I love you." That means something very specific. So when you don't want to name any variable function, you don't want to use the word function except for in this case. Okay, the function header is so important that MATLAB gives it to you already, gives you the skeleton. So we've got the blue word function. That tells MATLAB that this is a function header. Now in square brackets there, you'll see output args. I'm going to output the sum of my length 6 vector elements. And I'm going to call that sum capital S. So I'm going to change output arguments to capital S. That represents the variable that I am going to be outputting. Now, you'll see the square bracket, then you'll see an equal sign. and then you'll see untitled. We want to give our function a name, so this is like f of x or g of x. So I'm going to call my function sum6, okay, to represent that I'm going to be adding or summing all of the elements in a length 6 vector. So I'm going to give it a descriptive name. Then you'll see parentheses, so that's like f of x, the parentheses x, and then the input arguments. So the input to my function is a length 6 vector. I can call that vector whatever I want. Okay, we'll call it v. So there's the proper function, or a proper function header for this particular function. Okay, now you'll see the green comments summary of this function goes here. We'll want to describe what this function does. We'll say sum6 sums all the elements in V and returns sums all the elements in V. We'll say that. Okay, that's fine. And we'll put our name. Okay, and we'll put our date, the date. Last updated. Okay, I'm going to put the date here, 27/17. Okay, now I've got my comments. I'm almost ready to go. I want to save this. You see, right now it says this is untitled. Now, this is very important, and this is something we will always do in this course. I've named my function sum6. The file name must match the name of the function, always. So I'm going to go to Save As. Okay, and in fact it asks me, do you want to save this as sum6? Yes, I do, always. And I'm going to save it in my current folder. Save. And when you do that, you'll see sum6.m appear in your current folder. Notice it has a different icon than the previous examples. That's because it's a function. It's a MATLAB function. Okay. So now if I'm the function, I've received a length 6 vector. Now I want to add those things together. So my length 6 vector is v. I want to add those elements together. Now you could type v of 1, right? That's the first element of the vector, plus v of 2, plus v of 3, plus v of 4, plus v of 5, plus v of 6. Okay, you could do that. But to illustrate a point here that I'll bring up later, I'm going to perform an intermediate calculation. I'm gonna sum the first 3 elements. Okay, so let me do that. I'm gonna call that variable first half. Okay. And then I'm going to sum the second half. So I'll call that second half equals v of 4 plus v of 5 plus v of 6. Okay. And again, I'm adding the semicolons at the end of these lines because I'm not interested in having the function echo back to me what the first half is and what the second half is. I don't need that. Okay. Now, of course, I'm after both halves combined, added together. So now my output variable, which we are calling S, so it has to be S now, capital S, equals first half plus second half. Okay. and my function is complete. Now let's think about what's going on here. So now I've got a box. Here's my box. This is my function. V is not defined yet. Right? We don't know what V is at this point. But V is outside of my box. When I call the function, I will send it a V. Okay? Just like x squared plus 1, we didn't have an x yet. Okay, but we knew we were going to square it and we were going to add 1. So when we did get an x, we knew what to do. Okay? In this function, we don't have a V yet, but we're telling it what to do with V. Okay? Once we do get a V, we're going to take the first 3 elements of that vector V and we're going to add them together and store it as first half. Then I'm going to take the 4th, 5th, and 6th elements of V, add them together and store that as second half. Then I'm going to add the first half with the second half, save that as S, capital S, and then return, okay, as defined in my function header, S. Okay, and I've saved it. I guess I have not saved it since I worked on it, so I'll save it again. Save. Okay. Now, let's see how this works. In the command window, let me generate a vector. Let's say vector equals square bracket. I can choose any length 6 vector that I want. So let's say pi, and then maybe 4, negative 10, 0, 6, 3.2. Okay, I've got 6 elements there. I will close off the square brackets and put a semicolon there. Hit enter. Okay, now vector is stored in the workspace. Now I'm going to call my function. Here we go. I'm going to say, hey, it's called sum6, parenthesis, vector. Okay, so remember, vector is currently stored in workspace. So now I'm going to send that vector, that input, to the function sum6. It's going to do its thing once I hit enter. It's going to return back to me the number. Watch. There it is. That's the answer. That's the sum of all 6 elements. Now, that's pretty cool, right? What you may notice here is that it gives us A and S again. Okay, so it's stored, and the answer is stored as that default variable ANS. Maybe we want to save it as a different variable, maybe SS. So I can say SS equals sum6 vector. And I'll put the semicolon there. Actually, just to make this more dramatic, before I do that, let's clear the command window and clear the, no, let me clear answer. I'm going to clear answer, so I'm going to just delete it. So I've got vector still in the workspace. Okay, so SS equals sum6 vector. And I'll put a semicolon there. Maybe I'm not interested in the answer. Or at least I'm not interested in having MATLAB echo it back to me. So now I've got SS equals sum6 vector. So I push enter. Okay? It doesn't seem like it did anything, but it did, because in the workspace is now SS. Okay, so if I want to have a look at SS, I can type SS, hit enter. There it is. There's the sum of all 6 elements in this vector. Okay. Now, I want to point out a couple things here to you. Number one, notice that our vector variable name, okay, we called it vector, excuse me, it does not match the variable name v. What's happening here is that I can call the input whatever I want. In this case, I called it vector. And when I pass it to the function sum6, the contents of vector get copied into this vector v. Okay? And then the function operates on v. Also notice, similarly, that the output that I'm storing the answer as SS does not match the variable name in the function capital S. Okay, so this is the reverse process now. It operated on V, it found the sum capital S, it outputted capital S, and then it gave that back to me, and I chose to store that as SS. Okay, I can do that. That's fine. In fact, it's preferred. So let's think about why. Why is this allowed where I don't have to match those variable names? Well, let me clear the command window, CLC. Turns out when you download MatLab, the application, you also receive many functions written by MATLAB's developers. Okay, these are functions written by them, and they're stored in the package contents in the root directory of MATLAB. Okay, one of those files and one of those functions is a function we already looked at, length. Okay, it's hidden away from you so you don't edit it, but it works the same principle. Okay, if I want the length of that vector, okay, they have MATLAB, MathWorks has a script, or a function called length, where we send it in a vector, and it outputs, call it the output L, the length of the vector, 6. Okay. It works the same way as our new function sum6. But imagine if I had to match my variable name with their variable name. In order for me to do that, I'd have to find their function length, open it up, and see, oh yeah, they called their input vector v, so now I have to change what I'm doing to match what they're doing. And oh, they changed their output, or they called their output s, so now I have to change my output from L to S. Imagine what a hassle that would be if you had to match these things. So you don't have to. You don't have to. It's perfectly acceptable to call it whatever you want down here. MATLAB will just copy and paste it up here, operate on that, output whatever it wants, and then copy and paste it to whatever you wanted the output to be. Okay. All right. Now, I want to point out to you something else here. So let me clear the command window, CLC, and I'm going to clear the workspace other than vec, other than vector. And I'm going to run my function again. SS equals sum6. Okay, and I'll hit enter. Okay, now notice that after I've called this function, in the workspace is SS and vector. Okay, but nothing else. Okay, so vector came from me defining it before, and SS is the output of my function. Right? There it is. I've chosen to store the output as SS. But notice that first half did not get saved in the workspace. Second half did not get saved in the workspace. And capital S did not get saved in the workspace. So think about the implications of that now. If I wanted to look at what the first half of the vector summed to, I can't. I can't do it because it's not in the workspace. If I wanted to look at what the second half summed to, I can't. And if I got confused and I thought that should be looking at capital S, I can't. Capital S is not in the workspace. Okay? So a function keeps all of its variables local to the function. We say that the variables are local to the function. That's big here. I'm just going to write it real big here. Local. That is to say, this function is a black box. All of the calculations, all of the intermediate calculations, are kept under the hood, so to speak. It all happens in here, and you can't see what's going on in there. You can only see the output of the function, okay, which we decided to call SS. Now, let's consider why that would be a good thing. Okay? Well, it's not uncommon for functions, first of all, to be very long. Okay, our function only has 9 lines, but functions, there's no limit to them. They can be hundreds, thousands. And it's not uncommon for a function to use a variable v, okay, as we have here, or a variable I. Imagine we were running a couple functions, and each function used I, and each function used v. After I run one function, if its variables were stored in the workspace, I and v, okay, and then I ran another function that used I and v, there could be some crosstalk between those two functions, and I might get a semantics error. Something, it might be using a variable from another, the second function might be using a variable from the first function, and then some strange things might be happening. So MATLAB keeps all of these calculations under the hood. We can't see them. Okay, that makes debugging them more of a challenge, but once they're set, it keeps everything nice and clean. To illustrate this even further, let's write a script that does the same thing that we just did. Okay. So here's our vector. I think this was pi. Yeah. Okay, so I'm going to go to New, Script. Okay, I'm going to save it as sum6 underscore script. Okay. So this script I want to do identical. I want it to be identical in function to what we just did. So vector equals pi 4 -10 0 6 3.2. Okay. Then the next thing we did in our function, if you remember, was we calculated the first half, which was, I guess we used, yeah. So which was the first element of vector, the second element of vector, plus the third element of vector. Okay, the next thing we did was calculate the sum of the second half, which is vector of 4 plus vector of 5 plus vector of 6. Okay, then we said SS equals first half plus second half. and that should do it. So let me save it again. Save. Okay, now I'm going to clear the command window and clear the workspace. C-E-L-A-R there. Okay, so if you remember, a script is just a bunch of commands, and they're executed as if they would be if we type them in the command window. So I'm going to run the script. Run. Okay, and let me see what SS is. SS. Okay, I get the same answer, of course. Of course. But what's different? What's different than with the function? Look at the workspace. Okay, we've got vector, which is the vector that we are operating on. We've got the answer, SS. Okay, but look at what we have here. The intermediate calculations, first half and second half. So now I could look at first half if I wanted to. Oh yeah, there's the sum of the first half of the vector. And here's the sum of the elements in the second half of the vector. Okay. Let me clear. Remember, let me put vector back into memory. Yep. Now when I call my function, see, I don't have those intermediate calculations there. Keeps everything under the hood so that it cannot talk to other functions. It's not uncommon for one program to call tens or hundreds of functions. You don't want those functions to be talking to one another. Okay, so now that we kind of understand what a function is, we might want to know, well, why do we need functions? Why can't I just type everything in a script and be done with it? So we'll keep the same example. Let me clear the command window, clear the workspace. Okay, so I have this vector, right? There's my vector. And I want to calculate the sum of all those components. So I can do that with my function, sum6 of vector. I'll leave off the semicolon. There's the sum of all of those guys. Now let's say I have a new vector. A equals, negative 100, 4. It still has to be a length 6. Pi over 2, 11, 0, and negative 2. Okay, so there's my new vector. Length 6 vector. Now let's say I want to calculate the sum of all of those components. Well, I can do that easily. Sum 6, and I will put A as its input. So now I'm throwing it A, right? So in our math example, x squared plus 1, you give me 1, I give you back 2. Now you give me a different number, negative 2. I give you back 5. Okay? So now we're giving our function a different vector. And I give you a different answer. Consider now if I wanted to use my script to do this. If I wanted to use my script to do this, I have to go into my script, open it up, change this line, right? I have to recode my script because the vector was what we call hard-coded in the program. Okay, it's already been coded. The vector has already been coded. So for me to calculate the sum of that vector's elements in a script, I have to open the script up. I have to retype the vector, and then I have to run the script again. What a hassle. when I could just call my function, as I did here, with just a different vector. That's the advantage of functions. Okay, well, our function, let me open it back up. Our function had one input and one output. And we started this video, we said your function can have any number of inputs, 0 or higher. Any number of outputs, 0 or higher. I'll let you read the book to find out, how we make functions with multiple inputs or 0 inputs. But I do want to give an example of multiple outputs. So now, let me change my function. So I'm going to change my function, and I want not only to add all of the elements in that vector and return that sum, I want to add, or I want to return also the average of all the elements. Return the average of the elements. So the sum and the average, we'll call the average AVG. Okay, so now here's my model of our function. We're going to send it a vector, length 6. We're going to return or output S, the sum, and the average. Okay, what was the most important line of the function? The function header, the first line. If you get the function header wrong, then there's no hope for your function. If you remember, the MatLab skeleton helped us out. These were the output arguments here. So you need to place all of the output arguments within the square brackets, separated by commas. So I'll put a comma there, and I'll put AVG. So I'm just going to call the average to be AVG. Okay. So now I need to calculate the average in my function. So after I sum all of the elements, how do I get the average? I divide by 6, right? So I'm going to take AVG equals S divided by 6, semicolon. Okay, AVG equals S divided by 6, and I've got the average. So let me save that. Okay, I'm going to clear the command window, clear the workspace. Okay. And so let me show you. Let's define a vector. There's my vector. I'll leave off the semicolon. Now I want to capture both the sum and the average. So I need to tell MATLAB that I intend to capture multiple outputs. So the syntax for that is as follows. I need a square bracket SS or any variable name, comma, and then the other variable name. Maybe I want to capture the average as A, square bracket, equals sum6 of vector, semicolon. Okay, so in this case, what I'm doing here is this part has not changed. Okay, I've got a vector, and I put that vector in in parentheses, and I give it to sum6, our function. But here I'm saying, okay, do your thing on my vector. Okay, take the sum S, okay, which corresponds to the first output listed is capital S. So that corresponds to the first output listed here, which is SS. So it's going to take the sum and it's going to store that as SS. Then it's going to take the average, AVG, which is the second output listed here, and it's going to store that as the second variable listed here. And if I had 3, then I'd put comma the third one, comma the fourth one if I had 4. And I'm going to push enter, and there it is. So notice in the workspace, I've got A, I've got SS. Notice it didn't display anything to me. That's my option, right? If I wanted to display, I would just leave off the semicolon. But let me take a look. SS, enter. So, okay, that's the same as before. Let me take a look at the average. Average is 1.0569. A. Okay, so that's how we can capture multiple outputs. And finally, it's going to be a little bit picky here. Your function should always have semicolons at the end of each line. You really should not echo anything back in a function. Okay, let's say you thought, oh yeah, I'm calculating the sum. I'm going to want to see that. Oh yeah, I'm calculating the average. I'm going to want to see that. All right. So here's my vector, right? And I'm going to call, just as before, I'm going to call both of those variables. And so I'm the user, and I say, well, I'm not interested in seeing SS. I'm not interested in seeing A, so I'm going to put a semicolon there. So I want to keep my command window nice and tidy. Hit enter. But notice it still prints them out, even though I didn't ask it to. The reason it prints them out is because in our function we left off the semicolons. So now, as the user of this function, I don't even have the option of suppressing the echo because you, the programmer, left off the semicolons. Okay? Don't do that. Put the semicolons there. Save it. Give me the option as the user. Okay, let me clear. There's my vector. Okay. Give me the option. Okay. I'll put a semicolon there because I have the option. I don't want to see SS and A. I don't want them to junk up my command window. Okay. They're there if I need them. They're there. A, SS. They're in the workspace. Okay. But they're not junking up my command window. If I did want to see them, I have the option. I will leave off my semicolon. There they are. Okay. Great. Okay. So let's summarize here. Let's summarize the key points. Okay. First of all, functions can have any number of inputs and any number of outputs. Okay. We looked at an example with one input, one output, and then we changed it to one input, two outputs. The most important line is the function header. Screw the function header up, and you've got, you're doomed from the get-go. So the correct function header starts with the keyword function, and that turns blue. Then you put all of your outputs in square brackets, separated by commas, equals the function name we called sum6, but we'll just say the function name, parentheses, and then your inputs separated by commas. That's the function header. Okay, it tells MATLAB that, number one, you're writing a function. Number two, here are the inputs, here are the outputs, and here's the function's name. You always, always, always want to save the file with the same name as your function. Sum 6 in our case. Okay, we can give our function some comments. Say this is what the function does. The function, it keeps all variables under the hood, so to speak. All variables local. They're all local to the function. Those intermediate calculations cannot be accessed, so that you cannot talk. One function cannot talk to the other function. It's very important. Okay, all those intermediate calculations are suppressed. Also, the advantage to functions, okay, is that we don't have to change. Don't change the code or the file for different inputs. Okay, that's the advantage to having a function. You don't need to change the file. You just send it a different input and it does its thing on that new input, and it gives you back the corresponding output for that input. Okay, that's not what a script does. A script, as we showed, you have to open it up, you have to change what's been hard-coded in the script. Okay, so we don't want to have to do that. Finally, when we call our function, we're going to sit here. I'm going to show the command prompt there. If we only want one output, we can say, whatever we want to store that output, call our function's name, and give it the inputs separated by commas. Okay, that's if we had one output. Okay, if we had multiple outputs, okay, we would put the outputs in square brackets. Out 1. Okay, when we looked at that example, which is still in MatLab here. Out 1, out 2 equals the function's name, and then put our input there. Okay, and we did not do an example, but if we had an example where we had multiple inputs and multiple outputs, okay, well, you put your outputs in square brackets separated by commas equals the name, and then you separate the inputs in 1 with commas, in 2